I really enjoy this opportunity to talk to people that I normally couldn't get to speak with. Um, and so the translation is great. I'll try to speak, slow and smooth so that everybody can follow along with what I'm going to talk about today. So today we're going to give a talk called Drive Your Growth Rate. And the reason I say drive your growth rate is because I like to think about managing growth rate on a golf course like we're driving a car or a truck. We're going to manipulate the controls so that we can go the speed that we want to go. So we're driving safely and in control through the winding roads that is the turf grass road. So let's kind of get into that. Why do we even worry? Oops, sorry. Why do we even worry about growth rate? What's the big deal? Well, as a researcher, the reason that we worry about growth rate from a sciencey perspective is one, growth rate impacts where the sugars are going in the plant. So true definition of growth rate is how much sugar is being fixed or assimilated versus how much sugar is being burned during respiration. So if the plant is fixing or making more sugar than it's burning, it's growing. And if it's burning more sugar than it's making, maybe it's very shady site, over time that plant will weaken and slowly dwindle and die away because there's just not enough sugar to sustain itself. So when I talk about growth rate today, I'm not going to talk about sugar production exactly. Instead, we're going to focus more on the growth rate that we as turf managers see every day, and that is our clipping yield. So we need to be more precise in how we define growth rate. And today we're only going to talk about how are we managing our growth through our clippings in our yield, what amount of grass is in the bucket. Another impact, though, of growth rate, especially clipping yield management, is the requirements of nutrients and pesticide applications that we put onto our grass. If the grass is growing faster, that means the nutrients are being removed faster from our clippings. And so the grass has to sustain itself by taking up other nutrients from the soil. And so that's a big factor. That's an implication of growth rate. Pesticide degradation, though, is another one, and plant growth regulators too, which are pesticides, but sometimes we don't think about as pesticides. These products go onto the leaves, and the leaves grow, and so if the grass is growing faster, we're actually removing the pesticide at a greater rate. Even pesticides that go into the plant and can move inside the plant, they generally start to accumulate on the actively growing leaves, and those are the leaves that we're mowing. So we're again mowing those nutrients, those pesticides off quicker. That means we have to reapply them more frequently to maintain the levels of control. So for like plant growth regulators that make the grass grow slower, we know that they last much longer on slower growing grass like collar height grass than on greens height grass. And one of the big reasons why is that the greens height grasses are growing faster because they are mowed so short that the grass is trying to outgrow that really low mowing height. From a management side, though, there's also the secondary real benefits for why we worry about growth rate, and that is, can we handle traffic? Can we what's our recuperative potential? Can we recover from damage from insects, disease? Another one would be how's it impacting our playability and our performance? And so those are some of the things that we are constantly focused on. And so there really is this idea of how much growth rate do we have, and then how can we manipulate our inputs so that we're only applying nutrients and water and pesticides and plant growth regulators when we have to apply them, and not when we just apply them based on the calendar. If the application isn't required and we make an application of fertilizer, we're going to get a lot of growth rate and maybe too much growth rate, and that can be problematic. So how do the grass leaves actually grow? There's a hormone in plants called gibberellin or gibberellic acid. This hormone that when you put it in a plant makes the cell walls stretchier. So the cells are like balloons. And when the cell balloon is stretchier, if the wall is stretchier, the pressure of the water inside the cell can make the cell expand greater. And so we find that the lower leaves, the newly emerging leaves, are the ones that are actually actively growing. Older leaves just sit there until they start to slowly die, and then they kind of get overwhelmed by the newer leaf that is emerging from the middle of the whorl or the tiller. And so most of this gibberellin is being produced down here in the lower part of these actively growing leaves. And environmental stimuli like weather and fertilizer and plant growth regulators all impact the formation of this gibberellin. So if we're trying to manipulate our growth rate, we're really trying to manipulate the plant's production of this really essential hormone called gibberellin. If there's more gibberellin there, the grass grows faster. If there's less gibberellin, the grass grows slower. So there's a bunch of factors that all impact gibberellin production. They include environmental factors like light quality and quantity. Is it shaded or not shaded? What's the water status of the plant? Is the plant starting to get a little bit of water limitation? Before we can even see wilt, we would be able to, the plant will start to shut down and hold on to its water. Temperature is going to be a big one. If it's too warm or too cold for that plant, the plant starts to shut down its growth rate, and so we don't see as much gibberellin being produced. Mowing practices are a really big one. We put down, if you're, like I said before, if we're mowing greens at greens height, so you're talking about, 3 millimeters versus collar height, which might be, much higher, then the collar height grass grows about 40% slower than greens height grasses. So those greens height grasses, thinking about it from a sugar perspective, more sugar is going to be mowed off. More nutrients are being mowed off on greens. Pesticides and plant growth regulators are mowed off faster. And so we have a very different dynamic of growth rate on a green versus a collard. Nitrogen fertilization is a huge driver of gibberellin production. If that grass has any kind of amount of gibberellic acid available, it will respond by producing a big increase in gibberellin. So, if there's a little bit of nitrogen fertilizer available, the plant responds by making a lot of gibberellin, which promotes a big growth rate. So those are all factors that are impacting our grass growth rate. And then the brake that's going to kind of slow down the production of gibberellin is going to be our plant growth regulators, our PGRs. So how do the PGRs stop gibberellin? Well, they just work to limit this pathway. So these environmental pathways, or these biochemical pathways, take raw materials in the plant, and little proteins go along, and they turn these raw materials, these sugars, into these active forms of gibberellin, so GA1 here. So this is an active form. The plant sees this, and when it sees this, it actually goes and starts to grow like crazy. So we can put our class A or class B PGRs into the plant, and so that they can actually slow down the production of this pathway. So if the grass growth rate is starting to get a little bit too intense, we have a way of slowing it down with these plant growth regulators. Here's an example too of how light impacts the production of GA. And so this is some data from Jason Haynes, where they looked at growth rate of his 11 putting greens, and he was noticing that one of his greens seems to always grow 40 to 50% faster than the other greens. And why is this? Well, the reason is because that putting green is growing in shade, and this silly grass is trying to outgrow these big tall trees. And so what that means is the plant is making more gibberellin, and it's burning sugars that it is already limited for because it's growing in shade and has reduced light. It's ultimately going to start thinning out and dying and declining as a result of the shade. So what do we do as managers to minimize this, and how do we manage grass in shade? Well, one thing we do is we increase the plant growth regulator application on that potting green to slow down its growth rate. And then we actually reduce nitrogen fertilizer because nitrogen fertilizer also promotes a big increase in growth rate. So we want to do what we can to reduce the growth rate. So that kind of leads to what we're going to talk about today, and that is how do we drive our growth rate? And so I really like this idea of thinking about we're driving a car or a truck, and our growth rate really is the speed that truck is going down the road. And so if we're going to drive our truck, there's a couple things that we want to be aware of. One is how fast are we going? And this is something that I think a lot of managers, I'd say most managers, have an intuitive guess of how fast their grass is growing, but they might not have a very quantitative goal growth rate. So we'll talk about that. And then we have factors that are going to impact our growth rate. So there's factors that we as turf managers can impact, and that's going to be nitrogen fertilization and water availability. That's going to make the grass grow faster. If we start to use higher rates on our plant growth regulators, we can have more growth suppression. And then one difference that we have in driving a car that we don't have as turf managers is, and when we're driving a car, we get to pick which gear we're in. Are we in neutral? Are we in first gear? Are we in fifth gear? But when it comes to driving our growth rate, Mother Nature really is what is picking the gear. So if the temperatures are ideal versus if they're not ideal, you know, the growth rate response to fertilizer is going to be very different. If it's really, really warm outside, the effects of plant growth regulators is going to change. So when we're thinking about trying to manage our growth rate, we have to first of all know what is our goal growth rate, how are we going to measure that, how are we going to affect the growth rate with the accelerator and the brake, and then we have to just kind of be aware that we don't really get to pick which gear we're in. So we're going to have to manipulate the accelerator and the brake more frequently driving our clipping yields than we would in a car because Mother Nature is always changing the gear. So let's first talk about our managing our growth rate and understanding how fast are we growing, what is the speed of our growth, what's the speedometer like. And so turf managers are constantly trying to manage their growth rate. And so here's an example of a picture where I manipulated grass growth rate, not with nitrogen fertilizer or temperature or anything else. All I did was manipulate the amount of gibberellin in the plant. And so we can see the plant that is growing too fast is yellow because the grass is growing so fast, it can't take up nutrients fast enough. It can't make chlorophyll fast enough to keep a green color, and sugars are being burned very rapidly to support that growth rate. Then we have grass that's growing at just the right speed, and it's not growing too quickly. It can handle traffic, but it also has good green color. And then we have grass that is growing too slowly, and we can see the damage from the mowers, from the grass just being unable to recover. And so we're trying to, impact our moisture, our nitrogen fertilizer to try to balance that. But the thing we have here is, it's great to just roughly say, is the grass growing fast or slow? It's better, though, to have an actual goal. And so we need to define what our clipping yield goals are more precisely and not just say, well, it seems like it's growing fast enough today or growing slow enough. Like I said, most people have subconscious goals that they don't even realize. So let's take those subconscious goals and turn them into real numbers that we can try to manage for. So how do you collect clippings? It's not very difficult. As you go out and you mow your grass with a bucket on it, as you're going to dump it, before you dump the grass, you just put it into some type of a bucket, some kind of a barrel, some kind of a vessel that has lines on it that you can measure how much grass is there. It could be something as simple as, a 5-gallon bucket that you would use for painting. And on the inside, you would just take lines and you draw a line every inch or and then as you watch that, the clippings start to accumulate, maybe there's a line that you say, when I mow green number 1, I want it to be at line number 4, and that's my goal. Or you can be more quantitative and you can look at very specific numbers, like I want to collect 100 liters of, or 4 liters of clippings off of green number 5. Or even better would be I want to get 2 liters of clippings per 100 square meters of grass that you mowed. So there's different ways you can do it. You can do it from the very simplistic, just how many buckets did we collect today when we mowed our greens, all the way up to how many liters per 100 square meters of clippings did you actually get. And so those are different ways of doing it. If you use a triplex mower, a lot of people just use the bucket in the middle and they multiply it by 3 to get all 3 mowers together. Some people collect clippings from every single green. Other people just collect clippings from a putting green or a green that they know is representative. The idea here is if you're going to manage all of your greens exactly the same, then let's just look at the green that's representative of all of those greens. Because if you're not going to manage greens differently, it doesn't do you much good to say, oh, I know green number 1 always grows faster, but I'm just going to treat it the same as the other greens. If you are going to treat all the greens differently, maybe with a GPS sprayer or variable rate technology or different fertilizer rates, then it would make sense to measure those greens separately. So here's some clipping yields for my grad student collected over the last summer in Nebraska. And you'll notice that there's some big peaks and valleys in there. And some of those peaks and valleys are the result of weekends where they didn't mow and then they came back on Monday and mowed. But other peaks and valleys are the result of time of the day, time of the year and water availability. And you'll notice there's a lot of fluctuations in there. Sometimes it's growing a lot and then it's slow, then it's high again for a day, and then it's really slow for a day. And then it starts getting faster again, and then it starts slowing down again. So what we like to recommend doing is looking at a 7-day average growth rate. So what you do there is just look at the prior 7 days of clipping yield, and then add those together and divide by 7. And then you can get an idea of at least, what kind of growth rate you had over those 7 days. And so if you're doing that, you start to say, okay, well, I see periods where the grass was growing pretty rapidly. I see another period where it was growing pretty rapidly. There's a period in here in June or late June where it's growing very slowly. And there's a period where the growth rate is fairly steady, although there is a lot of day-to-day fluctuations. So the question is now, how much growth rate do we need? So for example, if we're trying to have a growth rate of 0.3, you'd say, okay, at this period here in late June, and then in August, we're growing a little bit too slow. So maybe we need some more fertilizer there. And then there's periods here where the grass is growing too fast in May and early July. And those are situations that we'd say, let's go out with a higher plant growth regulator rate application to try to reduce our growth rate. So instead of just using the same fertility rate and the same plant growth regulator rate over and over and over, now we are actually, managing based on what our clipping yields are telling us. So we had this question, how much growth rate do we really need? And is there an optimum growth rate on our grass? So we did this experiment where we had different levels of traffic from that traffic simulator. I think when the movie plays, it might have muted me, or at least it muted my sound. So I don't know if I lost you there or not. But we did different levels of traffic on bent grass greens and bent grass fairways. And this concept goes to any grass species or any different mowing height. What we wanted to do here is figure out what growth rate did we have in which the grass was growing so slow that it didn't have good enough quality. And so our theory here was that if the grass had more traffic, it needed more growth rate to sustain that level of quality, but that the growth rate is going to need to be our fertilizer level is going to need to be higher to maintain that level of quality. So here's an example of that. So we have our green that has different levels of traffic on it. We have 0, 1, 2, or 3 passes a couple days a week with a traffic simulator. Then we split up those strips to receive different levels of nitrogen fertilizer, ranging from 0 to 0.4 pounds of nitrogen per 1,000 square feet. Okay? So we have obvious differences here where the ones that got the most amount of fertilizer looked good, but you'll notice that if it had no traffic, the 0.4 maybe even is a little bit too green. It's a little too lush, it might be too slow. Where we had a lot more traffic, the 0.4 looks about the same as the 0.2 without traffic. So we've doubled the amount of fertilizer, but we have very similar quality and performance. So then the question was, what was the clipping yields here? What level of clipping yield did I need to maintain either this quality or that quality, and are they going to be similar or different? So instead of looking at how much fertilizer we needed or how much traffic was required or applied, we looked at what was the growth rate and then what was the corresponding impact on the quality. What did the grass look like? And what we found was that when the clipping volumes started getting, the dry weight started getting around a half to 1 gram per meter squared, and that's a weight, and we don't recommend doing weights because that's very hard to do. It's the most accurate way of doing it, but pretty impractical for a golf course to use. So the clipping volume here would be about 1 to 2 liters per 100 square meters. When we were in that range, the quality was pretty acceptable. It wasn't too good, it wasn't too green, it wasn't too soft and slow, but it also was good enough that we weren't having really bad thinning of the grass. So now from that, we can start to have some goals for us to be managing for. So if you're interested in learning more about this, we have a YouTube channel and we post all this kind of research there. And so you can learn more about, what we're doing. This research is ongoing and it's something that we're working hard to share with the world through our YouTube channel, which is just youtube.com/UNLturf. Another nice thing of doing clipping volume measurements is it allows us to track what our clipping volume, our weights would be. Like I said, measuring weight is very hard. There's sand in the clippings, the moisture content in the clippings is always changing. But fortunately, the amount of volume that we get, the amount of liters that we get, can correlate really well to the weight. So for example, if we're getting 4 liters of clippings per 100 square meters, that's around 175 grams per 100 square meters. And when we convert to weight, the benefit of that is we can start to make some guesses about how much nutrients are needed to sustain that growth rate. And we find that both bentgrass and Bermuda grass have very similar lines where the volume and the weights are very similar to each other. 4 grams per liter, or excuse me, 4 liters per 100 square meters is similar to about 200 grams per meter, or 2 grams per meter. So really can be pretty helpful. If you would have zoysia greens, that number changes a little bit. For the bent and the Bermuda, it's pretty constant. But the important thing is here, as growth rate increases, nutrient levels, uptake levels increase. So what that means is if we're trying to increase the amount of nutrients that are in are being removed from our soil, that we need to reapply with fertilizers, the more growth we get, the more fertilizer we need to have. And so by tracking clipping volume, we can make some guesses about that. So here's some data from a golf course in the upper Midwest part, northern central part of North America, where they collect clipping yield every day from all of their greens. And we see some periods where right after the snow melts, there's a very rapid growth rate. And then as the soils start to warm up, we see actually a reduction in clipping volume. And then in the middle of the summer, when it's really warm and wet outside, the soils are warm and wet, we get a lot of breakdown of organic matter that releases fertilizer. It's like Mother Nature putting her foot on the accelerator. The growth rate increases, and then in the fall it slows down a lot. But if you look at converting what the clipping volume was per week and turn it into what was the total amount of clippings, how many liters did I get over the entire season, which is, I think, a number most people don't know right now. If I said to you, how many liters did you get this last year, you probably couldn't tell me how many liters you got. And if you can tell me, then we can start to make some guesses. And so from that, based at this golf course, we found that they removed about 2 pounds of nitrogen fertilizer per 1,000 square feet. But they only put down 1.5 pounds of nitrogen per 1,000 square feet. So what's the difference here? The soil was what gave you the extra 1/2 pound of nitrogen. So by looking at clipping volume, this manager was able to say, I'm under fertilizing because I'm relying on my soil, and eventually the soil won't be able to fill that gap anymore. So what can we do as managers to impact and manage our growth rate? Well, one is nitrogen fertilizer and water. So let's look at water first. If I go back to the clipping volume data from 2018 in Lincoln, Nebraska, we can see every time we had heavy rainfall events, we had a big spike in growth rate. And this is interesting to us. We don't really know why this is happening, although it's something that I think even every turf manager, from the highest end golf course to the person that takes care of their lawn, has realized. The thing is, we don't see these same growth rate spikes just by overwatering with our irrigation systems. It really is coming from natural rainfall. So what can we do to try to minimize these spikes? One thing we can do is just know that when we get rainfall events, we might get an increase in growth rate a few days later. But then depending on how we use our irrigation system, if we keep things very dry, then we're going to have a slower growth rate. And if we keep things very wet, we'll have a faster growth rate. So when it comes to water, it's better, can we actually detect and only apply the water when it's needed, so that I'm not keeping things too wet, which could lead to too much growth, but then not keep things too dry where I have wilt, and then we have all kinds of problems. So I'm going to show a quick video where you can see how we use thermal cameras, like in this image, to detect the water status of the turf. So here's this video of me going around and trying to find hot spots, and sure enough, I've located them right there. Those are areas that are running out of water. They are heating up just slightly, a degree or so Celsius, that's all. And that's an indication that we need to then check that area for soil moisture and water. And so that's great for trying to find hot spots. But the question we had was, how about scheduling when we have to water? And so we've been working with this system, this Hawkeye turf view camera system from a company called Corp in Virginia, United States. And they take pictures every 10 minutes, both thermal and visual, with our camera, and then we link all those temperature data and visual image data pictures to our weather data from an on-site weather station. So this is what our setup looks like. We have the camera system mounted on the pole, and then we have our research area. And in this research area, we have different levels of nitrogen fertilizer being applied, different levels of water being applied. And we have these big lysimeters in the ground, so we can actually measure how much water is being used by the plant. We can pull them out, we can measure them with a scale that can measure it to 40 kilograms with 1 gram resolution. So a really nice scale, so we can actually measure how much water did we lose today and get an idea of water use by that turf grass. So here's a plot area, the visual picture. You can see there's no real differences here in color from what our eyes can tell us, but the camera system is starting to see that the plots that had 0 water replacement are getting warmer compared to the ones that had 100% replacement. We also had plots here with these fine dots, 1, 2, and 3, in which we only watered when the camera system guessed that we are getting close to being dry, and we replaced water. And just to let you know, when we did that, we were able to reduce the water replacement by 75%. So that's a real dramatic reduction in our water needs. Led to more uniform growth rate because we never had big surges in it being very wet or very dry. And so I think this technology really does have some application. Here's a picture, video of us syringing, and it can also show us the benefits or the lack of benefits that can arise with syringing. So you can see how short-lived those syringing results are. This is over the matter of minutes. So let's look at some of the water content and try to figure out what is this thermal imaging really doing. And it's pretty complicated, and so this is stuff that we're building into the computer software, but we have our rainfall events here in millimeters, and we can see we have a really hot period, and this is the amount of water in the soil over time. So we are at field capacity, and then we had a dry down, and this is the treatment. We did not add any water back, and when we did that, we see a big reduction in the water in the plant. And when we had a water quality, or we had water content of about 4%, that's when we started to see visible wilt. So this is our obvious visible wilt point. This is what we don't want to hit, because this is what our eyes can tell us. This is when the grass is unhealthy. We tried 100% replacement and 50% water replacement, and we see that none of those treatments ever got down to the level of the wilt. So when we're trying to figure out, when do we have to water to avoid the wilt, we're looking at this really narrow window of about 2 days where the grass quickly went from plenty of water to wilt. And what was happening with the canopy temperatures there in this tight little window? So what we noticed is we took the temperature of the canopy, so the actual leaves, and we subtracted it from the temperature of the air. So what you'll see over the course of the day is at night, the canopy is actually cooler than the air by about 5 degrees C, and then it increases in the peak of the day. It was about 10 degrees C warmer, and then it cools back off at night rapidly, and then it started to warm back up. This is the dew starting to form as the air temperature is cooling to the dew point. The sun came back up, and so we don't have any water limitation. The green dots represent well watered, the red dots a drought, and we'll see that they're about the same. But as we get into this really narrow window of a day or two, we see our red non-irrigated plot is starting to get a little bit warmer than the control. And this small increase of 1 or 2 degrees Celsius is all that we need to signal that we need to water that night. If we do not water that night, what do we see? Visible wilt kicked in, and when the wilt kicked in, the plots that were not watered are now 10, 15, 20 degrees warmer than the well-watered plots, and about up to 30 degrees warmer than the air temperature. So huge increases in the temperature of the plot. And so the camera systems are allowing us to capture this, and they can help us schedule. And again, when we use these stress-based indexes, then we can actually water less and still have good turf health. So we'll skip that for time. An interesting thing too is that, like I said, those plots that were drier are actually cooling off more at night. And so this is another thing that we look for, and this is something that you could even look for if you had a little thermal camera system. Those pre-dawn water times were actually a little bit cooler because there wasn't any moisture there to hold on to the heat during the nighttime. So another thing that we're factoring in and we're managing is our nitrogen fertility level. And this slide got a little bit, I think, messed up on the translation. But the important thing I want to show here is that the growth rate of grasses are always responsive to nitrogen fertilizer. Normally, we're fertilizing way down here, 0 to 6 pounds nitrogen per 1,000 square feet a year. But if we could put down 3 and 4 times the amount of fertilizer that we normally would put down, and the grass will still respond. That means that the nitrogen is really like the gas pedal of our car or our truck. If we push that gas pedal harder, the engine will rev and it will go faster. Interestingly, when we're looking at our data from cool season grasses in Nebraska, and this is probably different than maybe in Spain, but it's just kind of interesting thing to me that, and I think it kind of shows what's going on from a managing growth rate perspective. We see that our growth rates out of the winter are very rapid right away in the spring. And one of the reasons this happens is because the grass is not growing in the winter. There's some fertilizer accumulating in the soil. And then when it gets warm enough, there's a bunch of fertilizer in the soil that the plant can use. And so it grows like crazy. Then it uses all that fertilizer. And then in June, we have our slowest growth rate. So this is times where we need to push the accelerator harder and we have to apply nitrogen fertilizer. Then in the middle of the summer, when the soils are warm and wet, we get mineralization. There's this breakdown of organic matter, and that releases fertilizer. And as a result, we see that the growth rate is very high. And this is real data. This is not just theoretical. This is what I think I see. This is what we actually measure in our clipping buckets when we measured it. This is a tall fescue. So these are times of the year where I don't need to fertilize because the grass doesn't really need the fertilizer. It's getting it from the soil. And then there's other times of the year, again in the fall, where the soils cool off and now the growth rate is slowing down and I need to put more fertilizer down. So one thing that we've been trying to do too is use sensors to sense the growth rate and the color of the grass. So recently we put a crop sensor, this Holland Scientific crop sensor, active sensor. It's put on the back of our mower and it has a GPS receiver on top. And so we can shoot some light down to the grass canopy, and then the light bounces back. And if the grass is really green, less of that light bounces back because it's absorbed by the plant. And if more light bounces back, then the plant is not healthy or it's bare soil. And so then we say the grass is very unhealthy and maybe it needs more fertilizer, maybe it has drought issues. And so there's different ways that we can there's different ways that we can measure this, and this is an area of very active research, but there's this scale called NDRE, which is something you may see more and more about when it comes to sensing nitrogen fertilizer, and that's very sensitive to turf nitrogen, and it's not very sensitive to water status. So it really helps us to figure out, is this area have high or low nitrogen fertilizer? So here's a video of some of the data we got from just one day of mowing our fairways of this par 3 golf course that we take care of. And so we can look and see the areas that might need a little extra fertilizer, a little more fertilizer. And so if we have a variable rate sprayer, we can go and hit those individual areas, or we can look at it on average. You know, is most of our grass not good, and we're going to go at a higher rate of fertilizer, or is most of the grass very green, meaning it has very high levels of growth, and then maybe I'll skip that fertilizer application. Again, we're using data to then go out and apply the fertilizer to adjust our growth rate. So how do we do it? Well, one way we've been trying to do this is just what will you do with your soil moisture meter? I'm sure many of you have soil moisture meters like the Spectrum TDR 300 or 350 or the Pogo soil moisture meter. And at your golf course, you know how much water you need to have in the soil to keep that grass alive. And we can use those same concepts to our golf course here at Jim Egger in Lincoln, where we know that if the number coming back from our sensor says it's less than 0.35, that means the grass is pretty lean. It needs more nitrogen fertilizer. So those areas will go at higher rates of nitrogen. And then we'll have areas that are kind of in our goal range of between 0.35 and 0.4. That's kind of where we want the grass to be. So that would be our normal fertilizer rate. And then if we ever get values greater than 0.4, then we have to say, okay, we need to put less fertilizer down because we're getting fertilizer A from the soil or from maybe a prior application of fertilizer that still has an effect. Things to think about though when you're doing stuff like this. Species and cultivars are going to have different numbers. Just like on your soil moisture meter, you're going to have places that need more water than other places, and so you have different kind of goal areas. Grass that's thin from the disease is going to have a low chlorophyll number because it's got disease problems. And even time of day can impact the measurement, especially for some of the passive sensors that are attached to drones. So this is a lot of research ongoing here, but I think it's something that we're kind of excited about where it's going over the last couple of years. You know, one thing that you can do now is pretty easy when it comes to scheduling your fertilizers. You can put down different levels of fertilizer on just strips to figure out, you know, how much N do you need right now to get the quality that you desire. So for example, this is a bentgrass, new bentgrass putting green for me. And I was using a standard fertilizer rate that I use at all my research plots, which gave me a quality of this. And it looks bad. This is a similar one right here. It wasn't good enough. So I went through and I just took a little sprayer and I sprayed different levels of fertilizer, and I realized, hey, I don't want to be fertilizing like this. I need to be fertilizing like this to get the quality that I need. And so we can do this with just a little hand sprayer, and you just go like one pass over, two passes over, three passes over, four passes over, just mark down the area and just watch how did the grass respond over the next couple weeks to figure out how you have to apply. If we have GPS sprayers, these are going to make it easier for us to do this because you could have a little calibration block area, and as you go on, it could automatically spray different levels of fertilizer, and you wouldn't have to do it by hand. And then you just go out there and look at, which fertilizer level is the one that you want to apply to your turf. All right. So that's the fertilizer, that's the accelerator. But again, when you're figuring out how fast your car is going to go, it's not all about the gas pedal or the accelerator. It's also important to know what gear you're in. And so that's where some of these growth potential models start to come into play. This is a model that was developed by Pace Turf and the Asian Turf. Micah Woods, Asian Turf Center, where they looked at, temperatures for grass growth rate, and from that growth rate, they figured out, what growth did they really need, or what kind of response to the fertilizer did they get. And so I think it's a good step in the right direction, although I think some of these models needed to really be, proven a little bit more with some real data, because when I look at, say, the growth potential that is anticipated from these types of models that use just air temperature, and look at the real world actual clipping yield that we see, in Nebraska, a textbook would say we'd have most of our growth in June and in September. But in the real world, we had most of our growth in early May and middle of July and early August. And that's because the soil available nitrogen level was the bigger driver. We had temperatures that were conducive, yes, but we also had a bunch of other factors that are in real world having an impact on our growth rate. So what I wanted to do was look at some of these actual real data to figure out, how does grass growth rate respond to temperature? So first we looked at Bermuda grass from University of Mississippi State University, and they wanted to figure out where was the temperature at which we'd have maximum and minimum growth rate. And so they found at about 12 degrees C for Bermuda grass, the growth rate was lowest, and then it was greatest at about 30 degrees C, and then it starts to drop back off above 30 degrees C. And that's average air temperature. So that's the average for the day, not 30 degrees for the high, but for an average. So pretty warm. And so what you can do is we can put in these kind of little increments here where we think about this in terms of which gear we're in. So I call this nitrogen response. If you put down an N rate, nitrogen rate, and it's very cold outside, it doesn't matter how much nitrogen you put down, it doesn't respond to it. And then if we go higher and higher in temperature, the clipping yield response will become greater and greater. So we looked at that for Bermuda grass. We did it for perennial ryegrass and found that its ideal temperature for nitrogen response was right around 60 degrees Fahrenheit. So right around, to be about 18 degrees, not even, it's 15 degrees Celsius. That's kind of where we're getting our peak growth rate. And so we'll see, even if we use a low rate of fertilizer or a high rate of fertilizer, they are both peaking at about the same temperature. So we need less fertilizer here to elicit a clipping yield response than, say, if it's really warm outside. Creeping bent grass is a little bit different. It actually likes it a little bit warmer. And so its ideal growth temperature is right about 24 degrees Celsius. So it's much warmer. And so again, the lower rate of fertilizer gives a bigger response. So like, for example, 1/8 of a pound of nitrogen fertilizer when the temperature is near the ideal will give you the same clipping yield as the temperature of a 1/2 of a pound of nitrogen fertilizer when the temperature is, say, +5 degrees. So we're seeing different responses based on temperature. So what that means is that when you're going out to schedule your fertilizer application, be aware of the temperatures. If we're seeing a lot of variability in temperatures, the response that we're going to get from that fertilizer is going to be very different. So when it comes to managing your nitrogen fertilizer, what you want to do is, use products, first of all, that are soluble. I really like soluble fertilizer sources. Why? They only last for a short amount of time, and they're immediately available. So if I'm trying to fix a low growth rate problem right now, I need it to be available now, but I don't want it to last for too long. And then just know that that fertilizer response is going to be impacted by things like if it's shaded or not, or if it's very sunny or not, or what the temperature is like. So that's, again, picking the gear. And so when we're outside of those ideal ranges for growth rate, we want to be, especially careful with how we're managing our nitrogen fertilizer, so we're not getting too much growth, or we're not jeopardizing or risking the environment either. So we'll wrap up here talking kind of about the brake pedal. And this is our PG. So this is the situation where the grass is just growing too fast. What are you going to do about it? Well, we can put down these plant growth regulators, and those really can help a lot. So things to know in the most general sense, and this is a whole multi-hour talk about plant growth regulators, and we're just going to do a quick 5 minutes of it here as we wrap up. I'm only going to hit the most important take-home points. Application rate, air temperature, and mowing regime all impact how a PGR is going to work. So those are the things that you have to be aware of. The duration of a PGR, for how long it's going to last, is dependent on air temperatures, or growing degree days, GDD, and how we mow. And the intensity of the suppression, how much growth suppression we get, is going to be a function of what rate we use. And they're separated from each other. So for example, if we're looking at how long a plant growth regulator lasts for, say, a putting green, if the median air temperature is 80 degrees Fahrenheit, so fairly warm, versus the median air temperature is 60 degrees Fahrenheit, a difference of just honestly, about 10 degrees Celsius, you're looking at either 10 days of suppression followed by 10 days of rebound, or you have 20 days of suppression followed by 20 days of rebound, just by a slight change in the temperature of the air. Why? Because these plants they're like reptiles, they're cold-blooded, and so when it starts to get cooler outside, they start breaking down these PGR slower, and so they last longer when it's colder outside. So growing degree days are a system that we use to keep track of all of these PGR applications and the temperature. So growing degree days are a pretty simple system. You just take the average air temperature each day, you add them together, and when you hit some kind of a total temperature sum, then we know that the PGR is likely gone and we can reapply it. So we can do it by hand. Again, very simple. Get yesterday's average temperature in degrees Celsius, add them together, and then when you hit some kind of a threshold, you go reapply the PGR and you reset your model back to 0 and start adding temperatures together again. If you are growing warm season grasses, C4 grasses, there is a base temperature of 10 degrees Celsius. So for example, if the average air temperature was 25 degrees Celsius, we subtract off the 10, we would get 15 growing degree days for that day, and we would add that 15 growing degree days to our rolling summation of temperatures. When we hit our threshold, say it's 200, we go reapply the product, and then you set it back to 0. So there's a lot of different models out there. We have about 570 now in the growing degree in our application called greenkeeperapp.com. So if you're interested in using this approach, sign up for greenkeeperapp.com, and all the models are freely available there. Here's just kind of an example to show you the impact of what application rate does to the duration and the amount of suppression that we get. And so this is done on creeping bent grass at fairway height grass. And so we see these models here where we apply Primo at day 0. After that, and then we have 100%, which is how fast the grass is growing at 1, if we never put down a PGR. So we put the PGR down, we have suppression. It bottomed out at about 200 growing degree days after we applied, and then it wore off, and we had a slight rebound, and then it wore off again. So at the low rate, we had 55% suppression on average, and the interval was 350 growing degree days. If we use the high rate, 3 times as much product, Now we get 80% suppression, including one day in which we had 0 growth rate. The suppression was so great. But our reapplication interval only went slightly longer to 380 growing degree days. So application rate is really how hard we're pushing the brake pedal, and the temperature is really how long that product is going to last. If you were doing ultra dwarf greens, since I think I gave a PGR talk a couple years ago with you guys, I wanted to just show some of our latest research that was done at all of these sites in the southeastern United States during 2016 and 2017. And we can see the PGR effects and how much stronger they are. And what we found for Primo Max was when we did a 4 fluid ounce per acre rate of Primo Max, the reapplication interval should be about 200 growing degree days. And you might think, Bill, that's very similar to what it is for cool season grasses. The important thing to remember is this is a base of 10, and for cool season grasses, it's a base of 0. Another interesting thing too is in all of our research at different sites, we never see a really strong rebound phase. The clipping yields just start to kind of go back to the level of the control over time. And so that's kind of interesting. I hear people say on their ultra dwarf grasses all the time that when the Primo wears off, the grass is growing like crazy, it's rebounding. In actuality, that's just how fast Bermuda grass grows if it doesn't have a plant growth regulator on it. So you might think, how much suppression does 200 growing degree days, what does that really mean in grass? And so if the average air temperature is 4 degrees C, and we take 4 and we subtract off 10 for our base, we actually get -6. We can't have a -6 growing degree days. It only goes to 0. So if our temperatures are really cold, we're getting 0 breakdown. The time it takes we have to reapply is very, very long. But if our average temperature for the day is, say, 16 degrees C, that means we're accumulating 6 growing degree days, base 10, every day. The Primo is going to last for 36 days. Heat it up to 21 degrees C. The average air temperature is now 11 degrees. Now we have a 20-day interval. We get warmer, 27 degree average temperature, 13 days. And if we're really hot, then we'd have a 22 degrees per day. So we'd be applying every 10 days. And so we can see how if we were always applying on, say, a 2-week interval, there's a lot of times where we're probably over applying, we're applying too frequently. And if we're applying, it's really hot outside, that 2-week interval may not be enough. And so we're not maintaining growth suppression. So I just wanted to wrap up by just reminding us what we have covered today, which is a lot, that we want to drive our growth rate, the factors that we can manipulate, our nitrogen fertilizer and water and the PGR rate. Those are the things that are easiest for us to really rapidly change. Get away from thinking, let's just do things based on calendars. Let's use models, sensors to reapply, to apply products only when they're needed so that we can keep our clipping volumes where we want them to be. We don't want them just fluctuating all the time. We should have some kind of a goal, establish it, write it down. It doesn't take that much time. It's less than a minute to write down your clipping yield from a green and put it into Excel, put it into our Greenkeeper app, put it onto a paper calendar, whatever. Just to kind of look back then and say, how have I been managing? What is my yield doing? And just kind of also then remember that Mother Nature also has a big impact on growth rate. And so we're constantly trying to manipulate our accelerator and our brake pedal to keep our growth rate where we want it to be. So if you're interested in learning more about our program at the University of Nebraska, we have our website, turf.unl.edu, and we have a Facebook page, and then a Twitter page that I'm on is @UNLTurf. So I have 2 big dumb Great Danes that I love at my house, and this is my backyard putting green, and I'm constantly trying to manage my growth rate there because they love to wrestle and play on the putting green. And you can imagine this guy here is very heavy. He's 100, or this guy's 180 pounds, and he's 130 pounds. So a lot of dog, a lot of traffic, and I'm constantly watching my growth rate and adjusting my fertilizers, top dressing, water to constantly handle their traffic. So with that, I think, can we do questions? Otherwise, just thank you very much for having me too.
Okay, thank you very much, Bill. It was for me it was a really interesting presentation. Just give me a few seconds to say something to the attendees in Spanish.
Yep.
Bueno, pues hasta aquí la presentación de Bill. Solo recordaros que tenéis en el apartado de documentos la presentación tanto en inglés como en español, por si os la queréis descargar, está disponible para vosotros. Y si podéis, bueno, creo que es interesante hacer las preguntas, aprovechar que lo tenemos aquí y lo que tenéis a vuestra disposición. Los podéis, si las queréis hacer hablando, os abro el micro y lo podéis hacer directamente o las introducís en el apartado de preguntas. De acuerdo. Hi, Bill. Sorry.
Yep.
Yes, just one. There are two questions.
Okay.
Could you tell something more about that? There is no rebound after PGR's application.
Yeah, we don't know why. It was a real big surprise for us to not see the Primo or Renew rebounding. So we don't know why this has happened. We sometimes see it on bent grass in Nebraska and Texas, which are very warm regions for cool season grasses in the middle of the summer. So the idea here is maybe the grass isn't making the gibberellum very actively during those time periods. But we don't really know why. But we have not been able to show it at 6 universities with some, top of the line researchers in weed science and plant pathology, and we keep seeing the same results. So I'm not really sure why. So just know that when your grass is out of regulation and the PGR is gone, that's how fast it would be growing if you didn't use those plant growth regulators. So I think people are kind of shocked about how fast the Bermuda grasses do actually grow if they're not under regulation.
Okay. Okay. Another question. How do we manage colors considering
Yeah.
clipping
So,
yield or
yeah.
to avoid color decline?
Yeah. So this is something that is a big deal right now, and I didn't have it in here for time. We got a whole extra 1 hour talk about collar decline. Essentially, what happens is the PGRs last much longer on collars than they do on greens. We also have places where you'll have cool season greens and you'll have warm season grasses on the collars. And so what happens here is you're applying your plant growth regulator for the collar, and I mean for the green, and you're overspraying on the collar. And as a result, you're applying the PGR to the collar sometimes double as frequently as it should be. And so I'll use the analogy of like if you're having too many drinks of alcohol and you're drinking the alcohol double as fast as your liver can break the alcohol down, you start to get a little intoxicated. Well, that's what's happening to the collars. We're applying too frequently, and that grass cannot handle that amount of PGR, and the growth rate gets really slow. So what can we do to help minimize this growth rate problem? One is we can increase fertilization rate on the collar. That's something our research is showing can be effective. Another thing we can do is use very, very, very low rates of gibberellin. And I don't know the metric conversion right now, but somewhere in the order of 0.1 ounces of active ingredient of gibberellin 1 per acre. So if you can find a product out there, you can kind of get an idea of what that would be. Usually it's very low levels. And you could just apply there and get some growth rate that way. Lowering your mowing height has been proven to help on some of these bentgrass greens because lowering the bentgrass collars, because as we go lower, it produces more growth rate. So that can help. Ultimately, the best thing to do is just try to keep the PGR off the collar. GPS sprayers or just being creative in how you spray can help.
Okay, great. Another question. This is from Roque Buendia. Is there any way to convert humid clippings to dry clippings when you measure the volume? Sorry.
Yeah, we generally find that essentially um, it's about So 1 to 2 grams or 1 to 2 liters per 100 square meters is equivalent to about zero point 0.5 to 1 gram per grams per meter. So if you're going to do one or the other, that's a pretty rough number, and it changes a little bit depending on how wet the moisture is. One of the things that we need to do as scientists is we need to standardize the clipping volume collection, because right now everybody has their own way of doing it, which is fine if you're only going to do it at your golf course. But if we're going to start comparing clipping volume from one course to a research plot, we have to have a much more standardized method of doing that. But in terms of just some general rule of thumb, that's generally the zero point 0.5 to 1 gram per meter is equivalent to 1 to 2 liters per 100 square meters.
Okay, great. And the last one, in a shady green
Yep.
with mixing with Ben and Poa, which would be the best strategy to manage the clipping yield?
Yeah, in the shady green environment, the first thing you want to do is use the PGRs, and use them at a little bit higher rate. But the one thing you'll know is that the interval gets longer in the shade, and one of the reasons is there's not as much sun to heat up the canopy, so the PGRs break down a little slower in the shade. So if you're going to use a growing degree day approach, you might be able to extend your duration a little bit longer, but then you can use higher rates to try to push the brake pedal harder and reduce that clipping yield, so that we can get the sugar to go to increase density, sustain rooting, and not go to outgrow a tree. And then also try to use lower fertility rates. The grass in the shade doesn't need as much nitrogen fertilizer on a cool season grass than it does in full sun. Most of that sugar, that nitrogen fertilizer is going to go make Rubisco, which is used to make sugar, and in the shade we don't get enough light, and so it's really a waste of energy. So we can just try to reduce our fertility rate and really try to use that PGR to shut down that growth rate in the shade. By doing those two things, that's really the best case to try to minimize shade issues.
Okay, so that was the last one. If there is anyone who is interested in asking any question to Bill Kreuser, so that's your time. Meanwhile, thank you again, Bill. It's always a pleasure
Yep.
to
Look
attend
forward to
and
doing it
listen
again.
your presentation. So the campus is always open to you. So whenever you want to come back, you are very welcome.
Okay, thank you.
Okay, so thank you very much. Pues, pues nada, si no tenéis más preguntas, pues nos despedimos de Bill Kreuser y nos vemos. Solo recordaros que el próximo 4 de marzo empezamos, bueno, tenemos un webinar organizado con Javier Reveriego, que es el director general del Club de Golf Valderrama. O sea que está más enfocado a directores, pero bueno, siempre es interesante tener el punto de vista de profesionales de este calibre, o sea que os invito a todos que asistáis. Y el 25 de marzo tenemos a Doc Soldat, que será también un webinar súper interesante. O sea que hasta la próxima y muchas gracias a todos. Adiós.